Hi everyone. Today I'm here with problem 2.63. I've been on a little hiatus because of exams and the holidays, but I'm back now. So let's get started. 2.63. A ball starts from rest and rolls down a hill with a uniform acceleration, traveling 200 meters during the second 5 seconds of its motion. How far did it roll during the first 5 seconds of its motion? Okay, so to better understand this problem, as per usual, we can start with a diagram. And so let's just say that this is our hill, and let's make this, there's a black ball right here, and it starts from rest. So we're gonna say VI is equal to 0 meters per second, and then we're gonna say that it rolls down the hill with a uniform acceleration. So we're just gonna have some like acceleration. We don't know what that is. And it travels 200 meters during its second. So you know what? We're gonna have to actually split up this little rolling down motion into two components. So let's say that this was the first part. Blue was the first part of its 5-second motion. And then let's just say red was its second part of that motion. So we have blue and then red. And we know that during this red portion right over here, that is when it rolled a total distance of 200 meters. And this happened during second 5 seconds. So we want to know how far did it roll during the first 5 seconds of its motion. So what was the distance during this portion? So let's start with all of our knowns. We can label them in by color. So VI blue was, we know, 0 meters per second. And acceleration, we don't know, but we know that it's going to be the same for red and blue. So, and then we can say that the time, we know that it was 5 seconds, right? So the first 5 seconds, and then, because we're talking about the second 5 seconds, right? The first 5 seconds, that's what we want. And then we know that our VF, right, so our final speed right over here is going to be the same as our speed, as our initial speed for red VI. Oh, I changed that into red. So, oh, color's not changing. Okay. So yeah, it's the same as VI, red. And so we have VI, we have A, we have T, and we have VI, VF, T, and A. All right, that looks good to me. That's what we know so far. And what about red? What do we know about the red portion? For the red, we know that our VI is equal to blue VF, right? So where the yellow star is. We know that at this point, the speeds are the same. We know that our acceleration is the same as the acceleration for blue. We know that our distance is 200 meters. We know that our time is 5 seconds. And we know that our, what are we missing? VI, oh, our VF, we don't know what our VF is. And I would argue, well, we have to find out if that even matters. But sorry, something that we're missing from this first part is that our D, this is actually what we're looking for. What's the distance? And so if we look at all of our known information right over here, we have, what we have is our VI on this side, we have our T on this side, and we have our D on this side, and we have our T on this side. And one thing that's kind of the same is these variables, right? We know that these are identical and these are identical. So because we we have two pieces of, or like two sets of information. We can make an equation from this information, and we can make an equation from this equation, from this information. What we have is we can create a system of two variables, two equations, two unknowns, right? Not two variables, two equations, two unknowns. So for example, using our knowns and unknowns for this blue portion, if I go ahead and write this into one of the 5 kinematic equations, so the one that actually has all of the parameters that we're interested in, I mean, we can use any of them because we want one, or actually let's get back to this one because this one's a little bit different. The blue one's a little bit different. So let's go back to our red just because this one's gonna be a little bit easier to set up because we don't, VF is kind of irrelevant. We see that we don't really share this information on this side, so why would we use it? So it's kind of irrelevant here. But what we do know is that we share these 4 unknowns with the left side, with the blue information. So let's go ahead and write down our kinematic equation that has all our variables of interest. So we have d VIT plus half of AT squared, and we can plug in our values, right? And then simplify. So VI times 5 plus half of A times 25. And then we have, if we just simplify this, we get 40 is equal to VI plus 5 over 2A. And then we can say, I mean, you can isolate for VI or A. I'm just going to isolate for VI right now, and we'll see in a second why. 40 minus 5 over 2A. This is what we have. We have our first equation that has 2 unknowns in it. Now let's look at our blue side. So we have our VI, we have our T, and we have our VF. And so what we can do is we can create another system of equations right over here, or we can create another equation, sorry, not system equations, we're doing that right now. And we can use this kinematic equation. And so what I'm going to do is I am going to plug in our values. So if we noticed, our VI here is also VF. So I can actually plug this 1 into this VF right over here, right? Because we said VI, red, is equal to VF as per right there. I just pointed an arrow at or circled. Okay, so then we have 40 minus 5 over 2A is equal to VI plus AT. And we know that our VI, when we in the blue component is, in the blue section is 0, right? So we start from rest, ball starts from rest. So this will be 0 is equal to AT, and T we know is 5 seconds because we're looking for the first 5 seconds of motion. So we have 40 minus 5 over 2A is equal to A times 5. And now all we have to do is isolate for A. So when I did that, I got 40 over 7.5. So our acceleration, our uniform acceleration is 5.33 meters per second squared. All right. So now we have our acceleration. We have our VI for blue. We have our VI now. That's our known. We have our acceleration because we just solved for that. And then we have our T. And now we're just looking for our D. So now we can use a kinematic equation that has all these variables in them. So our kinematic equation has all these variables in it, and D is equal to VI T plus half of A T squared. And we know that VI is 0, so we have D is equal to 0 plus half of 5.33 times 25. D is equal to 66.67 meters. And that's our final answer. So how far did it roll during the first 5 seconds of motion? Well, it rolled 66.67 meters. And that's our solution. So if you have any questions, please feel free to send me an email or leave your question in the comments. And if this is helpful, please don't forget to like and subscribe if you can. I would appreciate that so much. See you next time. Thank you. Bye.